In this video, we will talk about how to convert octal to hexadecimal. So, as a reminder, octal values are allowed to take on the values 0 through 7. Hexadecimal values, or sometimes they're called a base 16 value system, they take on the values 0 through 9, but once we reach 10, we instead use A to represent 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So with this in mind, let's work through a few examples of how to convert octal to hexadecimal. So let's say we have the octal number 5, 4. How can we convert this to hexadecimal? Well, what we're going to do is we're going to break out each individual value into, we call it 4, 2, and 1. And where do these values come from? Well, 1 corresponds to 2 to the 0 power, 2 corresponds to 2 to the first power, and 4 corresponds to 2 squared. And what you'll notice is that 4, 2, and 1, between these three values, we can represent any sum from 0 through 7, which is what the octal system actually is. So what we say is, how can we form the number 4 using just 4, 2, and 1? Well, we would just need the number 4 right here. So next what we can do is we can quickly convert this to binary, and then we'll go from binary to hexadecimal. So to convert this to binary, all we have to do is, if a number is underlined, we give it a 1. If it's not underlined, we give it a 0. So the 2 and the 1 get a 0. All right, we'll repeat this process with the 5 right here. So we'll say 4, 2, and 1. How can we form 5 out of these three values? Well, we would just need a 4 plus a 1, since 4 plus 1 is 5. And once again, we'll convert it to binary. So we'll say if it's underlined, it gets a 1. If it's not underlined, it gets a 0. All right, the last step is, starting from the right, we need to form groups of 4. So here's a group of 4 values. Notice we only have 2 values left right here. So what we can do is we can just add enough zeros so that we're able to form a group of 4. So we'll say here's our second group of 4. And the reason we're forming a group of 4 is because on this last step, we're going to write 8, 4, 2, and 1, which these values correspond to the hexadecimal system, because between 8, 4, 2, and 1, we can form any value between 0 and 15, which is what the hexadecimal system actually is. So we'll use a similar process where we say if there's a 1 right here, we'll underline the corresponding value in the hex system. So here's a 1, so we'll underline the 4. The 2 and the 1 do not have a 1 up here, so we don't underline them. So the very last step is, what is the sum of 8 plus 4? Well, that would be 12. But remember, in a hexadecimal system, 12 is represented by a C. So this will become a C. And then lastly, we just repeat the process over here. So we'll say 8, 4, 2, and 1. Notice only the 2 gets underlined because it's the only one with a 1 up here. So the sum of these values is just a 2. So our final answer is just these two values put together, 2 and C. So we'll say 2C. So the octal number 5, 4 corresponds to the hexadecimal number 2C. All right, let's try another example. Let's say we have the octal number 763. How can we convert this to hexadecimal? Well, once again, we're going to break out each of these individual values into 4, 2, and 1 to start with. So for this 3 right here, how can we form a 3 using these values? Well, we would just need 2 plus 1. What about the 6? How can we form a 6 using these values? Well, we would just need 4 plus 2. And for the 7, we would need 4 plus 2 plus 1. So once again, we're going to convert these to binary first. So if a number is underlined, it gets a 1. Otherwise, it gets a 0. So here, the 4 and the 2 are underlined, so they both get a 1. This one gets a 0. And in this last one, all of these numbers are underlined, so they all get a 1. The next step is we're going to form groups of 4 starting from the right. So we'll say here's a group of 4. Here's a group of 4. And notice this last one, we're going to have to add 3 zeros to create this last group of 4. Okay, so then we say, let's write 8, 4, 2, and 1. And we'll underline the values that have a 1 in the binary number. So we'll underline this one. We'll underline this one. We'll repeat the process with this group of 4. So 8, 4, 2, and 1. Notice all of these have a 1. So each number gets underlined. And then lastly, in this group of 4 right here, only the 1. So let's write 8, 4, 2, 1. Only the 1 gets underlined. All the others are zeros. Okay, so the last step is we're going to say, what is the sum of this group of 4? Well, we have 2 plus 1. That's 3. What about the sum of this group of 4? 8 plus 4 plus 2 plus 1. That's 15. But remember, in a hexadecimal system, 15 is represented by an F. So we'll say F. And in this last group right here, we have just the 1 is underlined. So this is just a 1. So our final answer is 1F3. So the octal number 763 corresponds to the hexadecimal number 1F3. All right, let's try one last example. Let's say we want to convert the octal number 4126 to a hexadecimal. How can we do that? Well, we'll start by breaking out each of these individual values into 4, 2, and 1. And then we'll ask, okay, how can we form the 6 using these values? Well, we need a 4 plus a 2. What about this one? How can we form a 2? Well, we just need a 2. What about, how can we form a 1? Well, we just need a 1. And for the 4, we just need a 4. So remember, we're going to convert this to binary. So if a number is underlined, it gets a 1. Otherwise, it gets a 0. So for this one, only the 2 gets a 1. For this one, only the 1 receives a 1. And for this one, only the 4 receives a 1. So the next step is we want to form groups of 4 starting from the right. So we'll say, here's a group of 4. Here's a group of 4. And here's our last group of 4. So now we're converting it to hexadecimal. So we'll use 8, 4, 2, and 1. If a number has a 1 up here, then it gets underlined. Otherwise, it does not get underlined. So over here we have 8, 4, 2, 1. So the 1 gets underlined and the 4 gets underlined. And lastly, we have an 8, 4, 2, 1. So only the 8 gets underlined since it only has a 1 right here. All right, so the last step is let's calculate the sum of these groups of 4. So we have 4 plus 2, that's 6. And this next group we have 4 plus 1, that's 5. And in this last group we only have an 8. So just 8. So our final answer is 856. So the octal number 4126 corresponds to the hexadecimal number 856.